recording has started. We are back with Tom and Epeolus. We're starting at couplet 16, and we're going to wrap at 2 o'clock. It is all you guys now.
Okay, so yes, where we were last time, we determined that the metasomal bands of hair are complete or at most narrowly interrupted in the specimen that we had. So that brings us to couplet 16. So here it basically separates Epeolus autumnalis from a bunch of other species. And so I'll just read the character. So actually, let me make my pointer bigger. I forgot to do that.
Thank you.
What did I have it last time? I think it was 5. Why it's so slow. There we go. Okay. I think that's what it was last time. Great.
Looks great.
So yeah, so I'll start with this character. So in Epeolus scutellaris, the axillae extend back quite far posteriorly, essentially to the end of the scutellum, if not further. So whereas in Epeolus autumnalis, it's not just short of the posterior margin of the scutellum, but also any bands of hair that you might find along with it. So I'll just blow up this picture here. So this is what it looks like in Epeolus autumnalis. You can see that the axillae clearly don't extend as far as to this band of hairs along the posterior margin of the scutellum, and definitely not toward the to the end of the scutellum. Whereas in Epeolus scutellaris, it clearly does. Let me just find it. I think it's this one.
I also notice that autumnalis in that picture is very dark, like there's no amber.
That is correct.
I don't know if that's 100%.
No, that is the next feature. So in Epeolus autumnalis, the axillae and mesoscutellum are entirely black. In Epeolus scutellaris, it is always, reddish brown, at least to some degree. The mesoscutellum may be largely black, but at the very least, the axillae are to some extent reddish brown. So yeah, I've not seen any Epeolus scutellaris specimens in which both the mesoscutellum and axillae are entirely black. There are some other species that key out in this set, that key out, following step 17. So Epeolus pusillus, sometimes you might encounter species with entirely black axillae and mesoscutellum, but not in Epeolus scutellaris. So this is the picture of the axillae and mesoscutellum of Epeolus scutellaris. And you can see that if the axillae don't extend all the way, to or beyond the margin of the mesoscutellum, at least it'll reach that band of hairs along the end. And so that's what that character means. And I think that was it. And in Epeolus autumnalis, you also don't see, let me just, if you look at T2, the apical band of hairs, there are no lobe-like extensions that come out in Epeolus autumnalis, but there usually are in Epeolus. There are in most of the species that come out later. I think in Epeolus scutellaris, it's kind of regional. In specimens in the Western United States, you see more cases of there being lobe-like extensions. Here, there's like a very faint one in this male. But in this particular case, that character isn't as strong. But at the easiest, the clearest difference is in looking in the coloration of the extilium mesoscutellum. So maybe this will be a good point to, for me to stop sharing my screen, and maybe Sam, for you to bring up your specimen.
And I'll say that it took me a while to figure out the language around that lobe-like extension. On both in mollies, because Epeolus is doing things too, and I think it's used even more widely because there's angles and things like that. So that was good to illustrate that and point at it, because it gets the words sometimes trap you.
And I'll add that Reitmeyer referred to those as lateral longitudinal bands. That was the terminology that that she uses in her papers. I used anterolateral extensions, but it's the same thing. It's the lobe-like extension of the T2 fascia or band.
Yes. Okay, so I'm not sure exactly where you want to see. We can dive more in here, but I think you can see, just like in your specimen, first of all, a lot of amber, and the tips, which would be right here. Maybe we'll go one more click.
Yeah, so I'm not actually seeing the specimen, Sam.
Oh, you're not?
No,
oh,
I'm seeing
I not share? Oh, maybe I didn't. You know what?
I'm seeing you.
Yeah, I didn't share. Sorry. How about now?
Yes. Perfect.
Okay. Great.
Yeah.
So ambery.
So that one has barely any black.
And then there's the tips, and it's clearly intersecting. You know, you can make arguments. This is one of the tricky things. Like, is that below the scutellum or at the same level? But by adding in, I like the addition of talking about the hairband at the rim there and intersecting as a measure of the in the key. You know, the more detail in a key, I like that, because sometimes you're like trying to figure it out, and you have several lines of evidence. That's very good. I like wordy keys. Right? It's a little personal thing.
And I'll just add that users should read the couplets carefully, because there are some that talk about the posterior extent of the axilla and relative to the posterior margin of the mesoscutellum, not just the band of hairs. So it's very important when flipping between couplets to actually read them, carefully and see what I mean when I talk about.
Right. And I think that's a general thing about keys, is that trips people up a lot of times, is like every word in a key usually has meaning and nuance, adds nuance, and can change the interpretation. And it's not like when you're reading a book, of course, you're not really reading every word. You're kind of, oh, I got it. I got the general concept. But in a key, precision is really important. So backing you up on that one.
Okay. Thanks, Sam. Yeah, so I think we can stop sharing. I don't think your specimen has those lobe-like extensions, does it? Or
let me just look on the side here. I'm going to look at my other microscope. Well, okay, this is probably good to talk about that in terms of what counts as a lobe and what doesn't. I think this is a good talking problem here. Okay, so I'm going to put it in on its side, and let me spin it a little bit here. Hopefully I'm getting it about where I want it. Let's get some focus on this. And okay, there's a little bit of glare. So I'm, okay. Yeah. So walk us through your thinking when looking at this.
Yeah, so in this one, there's like a trace of it, because you see a few pale hairs extending. Yeah, exactly. But it's not clear, well defined. But in this couplet, it may or may not be present, so that at least, so if you're not, if you're not sure, it still, allows for that specimen to key out in that part. But here, I would say it's somewhat ambiguous, because, it looks like there's, something there, but it's just not well defined.
Okay, Tom, I did not look at that couplet with my precision eyes at all. I was just listening to you talk. But here's the apical, so towards the end, rim band running along. And then, this is all the tergite. Here's the edge of the tergite, which is partially underneath now the B and lapping with the sternites. So what about this?
Yeah, so that's a good point. That part I wouldn't count as an extension. It's usually, comes a little, I should say maybe sublaterally might be a better term, because it's not all the way at the end of the tergite, it's a little bit before. And so what you were showing earlier is that like really faint extension. That's where a well-defined lobe should be. But because when you look at the end of the tergite, it's more just like that the fascia has expanded slightly toward the end. But that is, so that is a good point. And that's why it's good to look at the illustrations and see what what is meant by the term anterolateral extensions, to get an idea of that. It's much more obvious in the species Epeolus, pusillus, and the other members of that group. And maybe I should pull up, when you're done sharing, a couple of pictures of those. Sorry, you're muted, Sam.
I muted myself. So go ahead, take over. Okay. And I'll also point out that when I started out, I was using Mitchell because it was the main game in town. That was over 20 years ago. And then other people's, and then I learned that when I use the Andrina keys by LaBerge, and when I use the Mitchell keys, that I had to get a Mitchell mind, and I had to get a LaBerge mind in terms of like, how are they seeing and thinking about these things? And here we have the Onuferko mind at play.
Yeah, it gets confusing. So here, here's an example of a species that it's in the pusillus group. This is Epeolus basili, and in this specimen, here's where the fascia is, and you can see it's expanded here toward the end, where Sam was showing where there's there might be confusion about what anterolateral extension means, but what I mean by anterolateral extension is this big lobe here. And you can see it here too. You can see that this is separate from this, which I consider just an expansion of the T2 band. Is that clear, Sam? Okay.
What can you see from the surface? So the expansion part you wouldn't be able to see, right? But would you? Again, I'm not looking at a specimen, but would you, if you were looking at it from the dorsal view, would you see the expansion, or you really have to?
You can, but it depends. It'll vary per species, depending on the species, because some have them really like enlarged. In this one, you can kind of faintly just see. I mean, the forewing's blocking it, but you can sort of faintly see the extension here and here. I think there's another. Let's go to Nova Mexicanus or Nebulosus. Should have it as fairly. Yeah, it's much more obvious in this species here.
Oh yeah,
Nova Mexicanus. Right. So it'll vary, but I think when I refer to these images, which ones am I using? Okay, I'm referring to. Let me see. Yeah, so I'm referring to multiple views. Yeah. Both lateral and dorsal, because you can see it, in both, although in some views it's clearer than in others. I'll just close those because we're not going to be looking at those again. So I think it's pretty clear that this is not Epeolus autumnalis. I will add that that other paper to which I referred last week, in which a new species that described a new species since this came out, Epeolus emiliae. That key is modified for these couplets here. So I think the way it's structured is where Epeolus autumnalis is signed off. I think it's both Epeolus autumnalis and Epeolus emiliae. But if you're in the Western United States and you're keying these, then at this point I would be using the modified version of the key. But I'll stick to this because we're not keying that species, and also in that particular key, like I don't have all the figures hyperlinked because they're in this paper. So just for convenience, we'll keep using this, but it's just to note that there is an extra species and that's supposed to come out in here. It just wasn't described when this paper was written. So that takes us to the next couplet. Sam, is your specimen male or female? I can't remember.
On the autumnalis?
The scutellaris, sorry.
It was a female.
Okay. So that
I have males, I think.
Okay, that might be good to bring up a male, maybe of scutellaris and pusillus if you have one. So because those are the easiest to separate. So at this point, Epeolus scutellaris is separated from four species that together comprise the pusillus group, which is a tough group, and this is one that I resolved it to the best of my abilities, but I wouldn't be surprised if there were more cryptic species in this complex, especially once you get into Mexico, for which I've seen rather limited material. So this is probably the most the group within Epeolus that most needs to be looked at again at some point in the future. But if you're in the eastern US, Eastern North America, there is only one species, and that's Epeolus pusillus. So unless you're in the American Southwest, then you don't have to worry too much about separating out those other species. And Epeolus pusillus is one that is commonly confused with scutellaris. They're both late summer species or mid to late summer species. You often find them on Solidago and or further south on other plants like euthania, and they often occur in the same habitats too. So where I find Epeolus pusillus here locally, it occurs in an area where there's lots of scutellaris. So you're more likely to get scutellaris than pusillus. Pusillus seems to be less common, at least in the Northeast, but that may change, regionally depending on where you are. But those can be a little tough to separate. The males, fortunately, are very easy to separate from one another, and that's what this first character starts with. This is the sex-specific character, so it does not apply to females. But in males in the pusillus group, the mesopleura are almost entirely obscured by white cementum. And I'll show you what that looks like in this species here. So here's Epeolus nova mexicanus. You can see very little of the underlying integument. It's almost all covered in creamy white pubescence. And if you look at, let's see, scutellaris. And if you look at males, Epeolus scutellaris, you can clearly see that's not the case. There's sort of these large, sparsely hairy circular patches of pubescence that are separated by this more well-defined patch of denser pubescence. And so that's what the difference here is. So in Epeolus scutellaris, the mesopleura are obscured by white cementum only in the upper half, although the hypopemural area usually has sparser cementum, like I showed you in that image. Hypopemural area is the area underneath the base of the forewing. That's this area here. So yeah, and that's in this particular specimen, it's almost as sparsely hairy as the larger patch beneath. So, yeah, so with the large sparsely hairy circle occupying much of the ventrolateral half, and I've already shown you what it looks like in a member of the pusillus group. And then maybe at this point I'll stop sharing my screen and maybe let Sam bring up the specimens that you've got.
So I have a specimen here. It looks quite different, but I think it's still a scutellaris, so this will be fun. 'Cause I think you looked at all my specimens, so I would be surprised here if it wasn't. But this one has much more restricted amber, so we just have the outer edges, but still we have the tips across there. And anyway, the amount of red is quite different from the other, which people will recall the whole scutellum was pretty much red.
Yeah, it's a little odd, but often it doesn't hold 100%, and that's why you don't see it in the key. But often I find that in various species, females have, that have reddish brown or orange axillae, and the mesoscutellum, that coloration is more extensive in females than males. Not always. And there are exceptions. Sometimes you'll find females that look like the specimen that Sam just pulled up, but I find that is kind of a trend where females tend to have more extensive reddish coloration. The same is true in the species Epeolus australis, and it's very much true for a lot of old world species. A lot of old world Epeolus, I think you see even fewer exceptions, if any.
I see a review paper here because you could argue the same thing for Nomata, Sphecodes, and then just come to mind that have that same sort of pattern. Females
that's
are red.
true. That's right. Yeah, I forgot about Sphecodes too. A lot of the males are just black.
Yeah.
I have no idea why that might be.
And why would they be red to begin with, right? That's another interesting thing. It's because you theoretically, like in Sphecodes, it's really red. And you could argue the amber is more visible, but in theory, if bees are acting like the honeybee, if all bees act like the honeybee, then red is, basically a black, if I understand the color things well. So anyway, we don't need to go down that rabbit hole, but it is kind of interesting.
Yeah,
these things are so
thing
colorful.
I've always wondered about too is why in Florida red coloration is so much more prevalent.
Right.
There was a paper by Mark Darup several years back that documented all sorts of instances of red colored Hymenoptera and maybe some Diptera and other organisms, that have largely black counterparts in the rest of North America. It is an interesting topic. So yeah, in your specimen, it's without a doubt, this is Epeolus scutellaris, because you can see there's that very large, sparsely hairy patch, and then under the base of the forewing, the hypoepimeral area, it's also somewhat sparsely hairy. I found that to be the most reliable way to separate the males of these species.
I'm going to try and get I've got a bunch of pusillus, so I can try and put one on deck here. Yeah, so I find these in mostly sandy areas, probably because they're using Colites americanus or speculiferous and things like that. Is that a general pattern?
Those are the two species that I've tentatively associated with. As I think pusillus probably uses speculiferous further south and americanus further north. But yeah, I like where I know them to occur locally. We have Colites americanus and Epeolus pusillus. There's like a local dog park here in Ottawa with lots of sandy trails, lots of Euthymia graminifolia, and that's where I find the two. And I've also collected Epeolus pusillus. I think it was in South Carolina, along the beach, along the coast, coastal dunes. So that's yeah. So this is a great example, Sam. You can see that the mesopleuron is almost entirely obscured by white cementum. The axilli are usually somewhat smaller, shorter in this species as well, but it's such a subtle difference that I think, it might be, if you're comparing a specimen of what you think is pusillus and scutellaris, then directly side by side, then you might notice that the axilli and pusillus are a little smaller. But if you don't have both species for comparison, then it's a kind of a difficult character to use. So the mesopleural character with reference to the hairs is much more reliable means of separating these species.
I also find that. Go ahead.
Yeah, and I was going to say that I also haven't seen specimens of Epeolus pusillus where the axilli like clearly extend past the posterior margin of the mesoscutellum, but in Epeolus scutellaris they often do. Not always, but yeah, they often do.
Another thing that I notice is that on T1, that it's not super visible here, but the oppressed white hairs here just fill the whole front facing, the anterior face of it much more consistently than in scutellaris too. Scutellaris will often have, again, not the greatest view of this, but there'll be a large bare patch in there.
Yeah, I think that might be a regional thing, because I think in if I recall, Epeolus scutellaris from Western North America tend to have much more better developed pubescence, and that's where you get, for example, specimens with those anterolateral extensions. But for in the East, I haven't looked too closely at that character, but I wouldn't be surprised if that held up. Just for the region. Oh yeah, and there's that anterolateral extension.
Yeah, that's very obvious on that one.
Mm-hmm.
And they're a little bit smaller, if I remember right.
I beg your pardon?
Aren't they a little bit smaller, pusillus, if I remember?
Well, that means the name means dwarf or small, or so.
Okay.
But there are some. I think on the whole they generally are slightly smaller, but there is quite a bit of overlap. So, it's they are fairly small bees, but I have encountered some pretty small scutellaris at times too. So it's not, I would consider that, a secondary kind of character that may help you gain confidence in your ID. If if you're looking at all those characters mentioned in the key, and then in addition to that, you're noticing that it's quite small, that's,
right.
help
These
you
are where
kind of confirm your ID.
Yeah. This is where having access to, or having a large collection with big, sets of specimens, so you can, line them up. And so a lot of times, like pusillus will often just sort of, and this is just a general example, it's like, that's different. I don't know exactly why, but the vibe is different. Might be smaller, more hair, a little bit whiter. And then you have to drill in and figure out, well, is it, or am I looking at some variation? But a lot of times your gut is pretty good.
Yeah. And
I'm gonna
there
interrupt for a
are other
second.
kind of, sorry, go ahead.
As a next thing, so you said something before about what was the best way to distinguish the two, but you also have things in the key that refer to the pseudopygidial plate. If you would show that, because measuring those things is not a favorite thing for people to do.
Right. So that's for females.
Right.
Yeah. So I showed the most reliable way to separate males. Females can be a little more difficult. So maybe I'll start sharing my screen and then read that couplet, and then Sam, do you have any females of pusillus?
I'm looking now. Actually, about 15. So hopefully one of them is female.
Yeah, so this is a little, yeah.
Yeah, I do.
This is another case in which, having a ocular micrometer within the eyepiece would help. Yeah, people don't like measuring, but sometimes there's no real getting around it. But once you've seen enough of them, then then you could probably just gauge it. But let me just pull up. So in Epeolus scutellaris, the pseudopygidial area of the female is generally wider. Up this picture here. So let me remember which one of these is. C is the pseudopygidial area of Epeolus scutellaris, and then I have, yeah, D would be the, is there pusillus here as well? Yeah, D and E are what it'll look like in members of the pusillus group. So yeah, in general, I find that in Epeolus scutellaris, the pseudopygidial area is much wider. Clearly more than twice the lateral extent is greater than twice the medial longitudinal extent. Whereas here, you can see it's a lot narrower, and the lateral extent is, little, if at all, wider than the medial longitudinal extent. So I said, so yeah, in Epeolus scutellaris, it's about 2.5 to 3 times the medial length, and it's less than 2.5 times the length in the members of the pusillus group. Let me see what other. Yeah, and the other difference I also had, and I've already explained this, was that the axillae tend to extend a little further posteriorly in Epeolus scutellaris than in members of the pusillus group. So yeah, specifically it says, axillae, the tips extend to or beyond the band of pale tementum along the posterior margin. Whereas it, at most extends to the band of pale tementum, but not to the posterior margin of the mesoscutellum in the members of the pusillus group. And yeah, another often useful character is looking at the color of the mesoscutellum. In scutellaris, the mesoscutellum is often reddish brown to some degree, but as you saw with Sam's specimen, that is not always the case. Sometimes you get specimens in which it's all black. But in the members of the pusillus group, it's essentially invariably black. I think out of the hundreds of specimens that I've seen, I think I might have come across 1 or 2 aberrant ones where there was some reddish coloration to the mesoscutellum, but I consider those aberrant specimens, and it would be very, rare if you came across any member of this group where the mesoscutellum was to any degree reddish, but it's quite commonly reddish in Epeolus scutellaris. So I think at this point I'll stop sharing my screen. And
another question there. So you keep you're words. You're using the term pusillus group, but not always using the group term. So would you give us also a definition of what you call, what you're kind of lumping together when you say group?
Yes,
and who's in it?
Good point. So basically, the other species that are separated from Epeolus scutellaris here, all the ones that 18 leads to, are in the pusillus group. That includes Epeolus pusillus, and then these 3 southwestern species: Epeolus basili, Epeolus nebulosus, and Epeolus novomexicanus. Those, before this revision, they would have all been regarded as Epeolus pusillus, but this is these are what I recognize as cryptic species within that complex, and a very useful thing to look at, in addition to the morphological differences, is their geographic ranges, because these species are confined to very specific geographic areas that may show very little overlap. So that is a useful thing to look at when you're keying the members of that group. But yeah, It's those four
And
species.
Are they following Calides species? Is that your thought too? Or is
Yeah.
it just a isolation from my desert ranges and things?
So Epeolus basili, I think it's been collected by many people in the area where the bee course is held, and many of them, many of the collections, or you know, yeah, I think at least several series collected by different people have collected that species with Calides tectiventris. I believe that's the. Let me just double check that. But I think, if I recall correctly, tectiventris was the tentative host of that species. And then, as you mentioned, for pusillus, it's Americanus and speculiferus, and I think Nova mexicanus might have been collected with ciliatoides, but let me just double check that because it's been a while since I've written all this. The computer's being very slow today for some reason. Did I stop sharing my screen? I think I did, right?
You did. Yeah.
Okay.
There's no sharing.
I don't think you need to bring it up, but I'll just double check just want to make sure. So host records, yeah. It's been collected east of Wilcox, Blue Sky Road, in the presence of large numbers of Calides tectiventris. So that's the species Epeolus basili. Maybe I'll share my screen again just to show the range of that species.
Yeah.
Yeah, so here's the range of Epeolus basili. It's strictly southwestern, and most of the specimens that I've seen are from this area. They do barcode as distinct, and the barcode divergence is quite big. It's from that of the other three species in this group, even though the morphological differences are fairly subtle. And let me see what Nova mexicanus, I don't know if it was ciliatoides or one of those records. Yeah. So Torcho, I think this was from collections in Utah. Yeah, near Delta, Utah, collected what they refer to as Epeolus pusillus, but I've since recognized as a separate species in association with Calides ciliatoides. So that adds further, evidence that they're not the same thing as Epeolus pusillus. I mean, it is possible that the species is very, I mean, there is always the possibility that the species is quite plastic in its host choice, but it makes sense for Epeolus pusillus to go after both Calides americanus and speculiferus, because those two Calides species are presumably sister to one another, or at least very closely related. But ciliatoides and tectiventris are quite different from as far as Calides go.
Right. I mean, the interesting thing, I believe that Calides ciliatoides is in the same group as Calides ciliatus, which were and both we feel are probably daughter specialists, and you have an association, maybe tentative, of Epeolus andrii, yeah, on ciliatus. So in some ways it would be, it's not a tight story if a pusillus group is going to ciliatoides instead of something new.
Yeah, there's a lot of
andrii.
There's a lot of host switching. We'll go off on a little tangent here, but I'll bring up the results of a co-phylogenetic analysis that I conducted as part of my dissertation, just to give you an idea of how much host switching there has been. So this paper, unfortunately, is behind a paywall, but if anyone wants a copy, a PDF, feel free to, please email me, and I'll be happy to share one. And you can also do that via ResearchGate, because I have a the private text stored there. And so let's see what I have. Yeah, so here's, can't read that very well, but you can see that there are some, closely related Calides that are parasitized by closely related Epeolus, but there's also a ton of, host switching movements from, very different parts of the clades. Of course, phylogenies themselves are just hypotheses. These were based on a relatively limited number of genes too, so take that with a grain of salt as well. But I think it's still pretty clear that you don't have this case of perfect kind of co-speciation. Right. And I think that has to do somewhat with the fact that these aren't like ectoparasites that are living on their host. They're free to move around, explore, potentially new opportunities. There are observations of cuckoos often investigating nest entrances of bees that are not even in their host, that are not even in the genus to which their hosts are. So, yeah. They might not end up ovipositing there, but they are laying eggs there. But, but I think there's still, there are still cases where, where cuckoos may end up, laying eggs in what might not be traditionally their hosts and get away with it, So, I think that, would explain why you get, this kind of, what a tanglegram, as these are referred to. But anyways, that's a bit unrelated, I guess.
Okay, cool. No, sorry. Maybe it's only I that am interested in this, but I think that's cool. And it's, it's something that people aren't as aware of because it's harder to get that article, that journal article. So this is good.
But I
not just you, good to have recorded by the expert.
and it is, I mean, I do think it is, for the species for which hosts are well known or likely to be unambiguous, if you collect a series of specimens that you key as scutellaris and the only Calides that you got there is simulans, that is a line of evidence that you could use to build confidence in your IDs. Right. So it is, it is somewhat related to specimen identification as well. And so going back to, the couplet, I think we're all pretty confident now that, but the specimen that we initially started to key was scutellaris, and it's quite different from the members of that pusillus group. I don't know, with 15 minutes left, do we want to beg your pardon?
I could do a quick show of a pusillus female.
Oh yeah.
The pseudoprogedial area, just to
let's do that.
We can walk through it as a different thing in a less than pristine way.
Yeah, so that looks. Is that your pusillus?
Yeah. So there to there to there.
Almost like a, I wouldn't say an equilateral triangle, but like it's quite, yeah, it's clearly, I think I would say at most twice as the lateral extent is about twice the medial length of that, just looking at it. But I wouldn't say as great as like 2.5 or 3, as is the case in Epeolus scutellaris.
Yep.
Yeah.
Okay.
That looks. I can't remember if do you want to bring up a female scutellaris, or I don't think we necessarily need to.
I don't know that we need to.
Okay.
Yeah,
we're never gonna get out of this.
I don't know if this is too redundant, but in your key, there's also the flagellum, and the and the sternite rims being differently colored.
Yeah, I don't. Are you sure for couplet 17? I don't see anything there about the flagellum.
No, I thought we were still talking about pusillus. My bad.
Oh, okay. Oh, yeah. So, Yeah, I wasn't going to go and separate pusillus from these other species, but I can tell you that generally, yeah. So pusillus is the only one that you'll find in the east, and in that species, the flagellum is usually all dark brown, and so are the metasomal sterna. In the western ones, and especially the southwestern ones, they're the flagellum, at least ventrally, and the metasomal sterna are usually to a great extent reddish orange. So I think, yeah, I think in your specimen, I can't remember if we looked at the if those parts were visible, but yeah, in Epeolus pusillus, it's darker overall than the other species in that group. So I don't know, maybe we can try to quickly go through australis as a, I don't know if we'll get
Yeah.
all the way to
Do
the
you wanna
end,
hit-
but
Do you want to hit your share so we can see the key?
yes.
And I'll pull up an australis while we're doing that.
Just to minimize this. There we go. Yeah, so australis is an example of a species in which the axillae are quite small. It's also it's one that is good to, I think, show people because it is fairly well represented in collections, but I think it's often misidentified because there's not a lot of pictures out there of live specimens or photographed specimens for whatever reason. And so yeah, I actually maybe there are some on iNaturalist. Let me see if I could pull up some.
And now I'll put a specimen on deck too.
Yeah. Okay. So there aren't even, there's only one, looks like there's only one observation on iNaturalist of this species. But it kind of looks similar to some other bees, especially males, which don't, where in males you often get axillae that are all black, as well as the mesoscutellum, and females are usually ferruginous. But you know, this could be confused with a lot of things, and so I think it's just an example of a less commonly collected species that would be good to look at. So I'll bring up. Should be somewhere near the. There's. Okay, Andrea. Oh, right. I'm looking at the wrong. Couplet and a half should be very soon. Here we go. So that first couplet, if you recall from last week, we're looking at the posterior extent of the axillae. Here you can see it, you know, in this particular specimen, it gets to about the halfway point, clearly not as far as 2/3 the length of the mesoscutellum, or longer. And that's what that couplet is. So axilla and dorsal view with tip extending to less than 2/3 the length of the mesoscutellum. Yeah, Sam, do you have the specimen?
I do. Want me
Okay.
to share?
I'll stop sharing.
Okay.
Just because that's an important that's an important couplet, so I think it's good to give people an, you know. Oh, I'm not sure that that's I'm not sure that that's
and I got
australis.
Oh, because it's got hooked tips to the axillae. Yeah.
Can
I
you
mean,
zoom out? I think that might actually be somewhat unusual. That might be an unusual autumnalis. Which, yeah, I don't often see axillae that look like that. It's usually much more straight on the inside, but they also extend quite far back posteriorly. So that to me looks like autumnalis, but the shape of the discal patch on T1 is reminiscent of australis because it is kind of like that diamond shaped look. But the giveaway that it's not is the size of the axilla in this specimen, which extend quite far back posteriorly. I think, yeah, so this it's also a little tough to see because like one axilla, at that angle that you showed is looks like it's somewhat hooked, but the other one looks kind of almost, you could equally argue that it's straight along the medial margin and not distinctly concave. So this is it's a tricky specimen. But to me that looks like.
But it's too long, as you're basically saying.
Yeah, so the axilla are quite long, and in that particular one, it's not quite distinctly it's not so clearly hooked, like it's not really distinctly concave along the medial margin. It almost is a straight line. The one in the bottom, the left axilla, that one could, I could see why, that could be, one could see that as hooked, but
right.
I would, yeah, it's
okay. This is good because I think it's a Maryland specimen, and we're doing a revision of Maryland specimens. And yes, where is this from? This is from, PG County. So
it does go like
September.
Australis does go up pretty far north. I think if I recall correctly, you gave me a New Jersey specimen at one point, which was like that was the northernmost record I had for that species, but it was definitely Australis. So I would expect it to occur somewhere within the state. I just don't know where.
All right, so I'll rekey this with the notion that it has a high likelihood of being australis,
autumnalis.
Autumnalis, not australis.
Yeah, so I'll bring back my screen just to show the difference in the axillae between autumnalis and australis. I don't think you actually have any specimens then, unfortunately, that key out later, or you probably gave them all away to Lawrence or to me. Let me see.
Yeah, what else would be in there? I did
Minimus americanus. Yeah. So here's the difference between. Yeah, ignore the difference in coloration because there are males of australis in which the axilla and mesoscutellum are all black. But here's so I mean, you could argue that this is like slightly hooked, as so this is kind of where a judgment call has to be made. I don't know if actually
maybe we see an example of what is a hooked.
Yeah, well,
or direct eye comparison right this minute.
I think maybe, I don't even know if I have. Is australis supposed to be hooked to? I don't think I don't recall that, but I don't need, like, I think I would. I'm pretty sure that australis is also, scored in the way that it's supposed to be relatively straight along the medial margin. In a species where it's clearly hooked, like Epeolus lactoides, it's very obvious. Let me pull that.
So we're basically looking at the difference.
This is what I would consider, quite distinctly hooked. Like here you can see there's a very clear concavity that you can't really draw a straight line here without encountering quite a bit of, so I guess flipping between pictures if it helps,
that's really helpful.
this looks to me, relatively straight. Same here, at least when you're comparing it to species, directly to a species like Epeolus lectoides, where it's clearly hooked. Also, there are species in which the axillae are short that I also have scored as having, having the axillae hooked, but they're like, I'll jump to an example here. I don't know. I don't think they're mostly southeastern species, so I don't recall you having any SAM, but like in a species like Epeolus zonatus, the axillae don't extend past 2/3 the length of the scutellum, but they're kind of like angled laterally. And so here, they're still hooked, but they're not hooked as in lectoides where they're, where they extend quite far posteriorly. In this species, they don't, but there's still, a clear hook. They're just kind of angled to the side as opposed to posteriorly. But I think most of the species in this group are southeastern, with the exception of some rare ones like Epeolus gibbsi, which is known from only 2 localities in the US. And I don't think you have any of these ones, Zonatus, Origeranus, Lectus.
I think I did. I think I gave them to you because I collected them off of
probably
scrub palm in Florida, Georgia or something, which was, what is that called? Saw palmetto, which was very cool. It was blooming, and I think there were also Cleides on it too, but I don't remember which kind. But there's a bunch of Cleides down there.
Yeah, I can't remember if that's, but yeah, Zonatus is a Florida endemic. Interestingly, it doesn't form like barcodes of Epeolus zonatus don't form separate clusters from Epeolus illicus. So it's another kind of like, some might regard it then as a subspecies, but I think the morphological differences and the fact that they're geographically separated is enough to justify them as separate species, despite the fact that there's very little genetic divergence, at least when looking at barcodes. But this is essentially, I guess, if you were a lumper, you might consider that a red Florida form of Epeolus illicus. Let me just see if I can.
So I've got some more. I've got a box of autumnalis, and it does the specimen we were looking at that I had labeled as australis, which I'll have to look up and see whether it's in the database like that. Does look almost exactly the same, but the differential thing is between the two is basically length of the relative length of the axillae. So it should be a lot shorter.
Back they extend posteriorly, because the first couplet has nothing to do with whether or not they're hooked. It's just referring to how far back posteriorly they go. And so if you look at, I'll pull up autumnalis, and I'm just trying to remember where in alpha.
I'm gonna give us a wrap up warning.
Oh yes, Claire's got to go here in a second.
Yeah, I have a couple minutes of flex, but yeah, wrap up warning.
So we'll finish. I think we'll finish here. I'll just show the difference really quickly, just between just autumnalis and australis. So you see how far back they go by this horizontal blue line. Clearly not that far back in australis. Here you can see those anterolateral extensions are quite strongly developed, and they're very strongly basomedially convergent, forming a very strong acute angle. And that's what separates that species from a similar one found in the West, Epeolus brumlei. But I think, we'll leave it here, I guess.
Yep.
Yeah. So will you join us again next week? Are you available to do that?
I think I should be able to. I don't. So I don't. I'm trying to think of what specimens we might key. Then I think all the other ones. I mean, we could go through some of the, more common things like Epeolus bifasciatus. They'll all be in this sort of first.
I think there is real
split,
value
but I beg your
for
pardon?
you to, I think there's real value for you to be here and just even be talking about your wording and the keys, like doing the hooked, not hooked, flip back and forth is always helpful to have, you know, a one-on-one lesson with the material we'd be working with, even if we don't have the specimen on hand.
Yeah, and I suppose I could, you know, refer to images of, you know, on iNaturalist and things like that
Oh yeah,
too.
we did say that.
So yeah, we can continue next Wednesday. That shouldn't be a
Yay!
problem.
Thank you, sir.
Yeah, let
And then-
me let me just double check my schedule, but I think it should be free. I'll send you an
Okay.
email, Claire, to confirm.
Yeah, for sure.
You know, before the end of the week. But I'm going to
Perfect.
say tentatively, yes, I should be available.
Okay.
Also take the last second to remind that you have solicited pictures for walking through identification. So if anybody has pictures that they want to email, that could be an activity as well.
Yep.
Right.
Okay.
Yay, thank you all. Thank you, Tom. Nice, good new series.
Yep.
Thanks, Tom.
Look forward to
Yeah.
continuing. All right. Ciao.
I now have to hunt down the one more australis that I have in my database. You killed one of them, and I've got to go figure out where that other one is. I have notes that I'll have to look up. So it's good.
You should also, like, I thought you might have some minimus. That's also a species with short axillae, but
Really?
because I think, didn't you collect in the Dakotas at some point?
You mean like I have collected some, but I think again you may have those because I think I have. Yeah, I have an